Hello, 6th graders. We are in Unit 11, our geometry unit, and we are looking at 10.4 and 10.6. The first part here is 10.4, which is triangles, and our learning target that we need to write down is I can identify and classify triangles. All right, some vocab words that we'll go throughout the video. Triangle, congruent segments, acute triangle, obtuse triangle, right triangle, scalene triangle, isosceles triangle, equilateral triangle. So think about the words that you already know, and then we'll go through all of these to make sure we know them all. But a triangle is a figure with 3 sides and 3 angles. And we use this symbol here to show triangle. And there's a relationship among the 3 angles in a triangle. In this box here, it tells us the angles of a triangle, they all add up to be 180 degrees. So if we added whatever x was plus y plus z, they would all equal 180 every time. So we have a couple examples here where we have to find the missing angle measure. So in the first one, we have 2 of the angles so far, and we're looking for angle z. And this is our angle symbol, so angle z is what we're looking for. So we start by adding the 2 that we have together, so 43 plus 119. Well, 43 plus 119 equals 162. Okay, now they have to total up to be 180 degrees, so then we take 180, subtract off what we have so far, so 180 minus 162 equals 18, so the measure of angle z equals 18 degrees. Our next one here in this triangle, triangle ABC, if measure A is 25 degrees and measure B is 108 degrees, we want to find out the measure of angle C. Again, add what we have so far. There we go, 25 plus 108, which equals 133. Again, subtract that off of the 180 that we have to have total, because again, every triangle will always add up to be 180 degrees. 180 minus 133 equals 47. So the measure of angle C equals 47 degrees. All right, the frame of a bicycle shows a triangle, and we have to find the missing angle measure. Again, add what we have so far. 89 plus 60 equals 149. Subtract that off of 180 minus 149 equals 31 degrees. So our missing angle has to be 31 degrees. All right, so here's how there's different ways that we can classify triangles, but some things to know is that every triangle has at least 2 acute angles. One way that you can classify a triangle is by using one of the angles, the third angle, and the other way that we classify triangles by their sides. Sides that are the same length are called congruent segments. Okay, congruent means equal. First, you can classify triangles by angles. So first we have an acute triangle where all of the angles are acute or less than 90 degrees. There's a right triangle where it has one right angle, which is 90 degrees. And then obtuse triangle is where one of the angles is obtuse, more than 90 degrees. Or you can classify it by its sides. If it has no congruent sides, so all of the sides are a different length, that's a scalene triangle. If 2 of the sides are the same, that's isosceles. And if all 3 of the sides are the same length or congruent, that's an equilateral. Okay. Something to note here is this study tip. Congruent segments, the marks on the sides of the triangle indicate that they are congruent. So like on this isosceles, they have two lines here, which means those two sides are the same. So now if we look at our examples here, okay, this first one, this house, well, it has two sides that are the same, which makes it an isosceles triangle, okay, two congruent sides. And this angle here is more than 90 degrees, so it's an obtuse. So, obtuse isosceles. This tent here, this angle is less than 90 degrees, so that means it's acute. Again, two sides are the same, so that's going to be isosceles. So it's an acute isosceles triangle. And the last example, we have this 90-degree angle, that box in there. If I zoom in, that box means that it's a 90-degree angle, which means it's a right triangle. No sides are the same length. None of them have a tick mark on them saying that they're the same, so it's a right scalene triangle. All right, so that was all for triangles. Now we're on to quadrilaterals. This is 10-6, and our learning target is I can identify and classify quadrilaterals. All right, so again, some vocab for this section: quadrilateral, parallelogram, trapezoid, and rhombus. A quadrilateral is a closed figure with four sides and four angles. Quadrilaterals are named based on their sides and angles, and the diagram shows how they are related. Notice that goes from the most general to the most specific. So quadrilateral is the most specific way to identify something, and then all the way down to a square. Okay. The name that best describes a quadrilateral is the one that we use, or is the most specific. So, and if a quadrilateral has all the properties of a parallelogram and a rhombus, then the best description is a rhombus, because that's the most descriptive, most specific. And if it has all of the properties of a parallelogram, a rhombus, a rectangle, and a square, then we use the best descriptive one, which would be a square. Okay. And something to note here, parallel lines, the sides with matching arrows means that they're parallel. So example on this trapezoid, these arrows are the same, going the same direction, and it's just one arrow. That means they're parallel. This parallelogram, these two are the same, so those two sides are parallel, and then those are the same, so those two sides are parallel. All right, just like how a triangle had where all of the angles add up to 180 degrees, same thing with a quadrilateral, that all quadrilaterals can be, their angles add up to 360 degrees. Okay, because a quadrilateral can be separated into two different triangles, and the sum of each triangle would be 180 degrees, so 2 times 180 is 360. So you should make sure to write this down, that all quadrilaterals add up to be 360 degrees. Okay, so finding the missing angle measure. Again, just like we did with triangles, we add up what we have so far. So we have 59 plus 73 plus 85. And what you're really doing is you're adding x, and that will equal 360. So you add up what you have so far. So 59 plus 73 plus 85 equals 217 plus x, which equals 360. And to solve equations, do the opposite. Since we're adding here, we're going to subtract 217 from each side. So 360 minus 217, x equals 143 degrees. And it's always good to check that angle x looks like it's obtuse, so it makes sense it's more than 90 degrees for our angle measure. Next one, again, add what we have. 48 plus 157 plus 55 plus x equals 360. Add each of those together. This equals 260 plus x equals 360. Subtract 260 from both sides. 360 minus 260 equals 100, so x equals, 100 degrees. All right, so that is all that we have for 10-4 and 10-6 angles or triangles and quadrilaterals. If you are still confused, you can go back and rewatch the video. You could look at examples in the textbooks. Otherwise, head over and take your 10-4, 10-6 self-check quiz.